Okay, confirm the midterm as of today will be conducted on 24th of June, Saturday, 9:30 to 11 a.m. at DEXA. Wong Jianming, any objection? Midterm, move to 24th, Saturday. Any clashes? Can I? Okay. Okay. Then we proceed to our enzyme topic. Okay, from your previous exercise, you had done on the enzyme substrate, how enzyme works, the lock and key and induced speed model. Okay, so basically in general, the enzyme, this is how the enzyme attach, means react with the substrate to produce the product. Okay, so there are 3 steps. Step 1, enzyme and substrates combine to form complex. Okay, so enzyme with the vacant site attached with the substrate, then it will form a complex between enzyme and substrate. Okay, so this is the first step. Next step, when the enzyme and substrate combine, then it will start to produce the transition state, which is producing the product. Okay, step 2. Enzyme product complex is formed. Okay, so you have ES. From ES, you have EP. P here refers to product. Substrate, transition state to form the product. Okay, this is step 2. Step 3 is when the enzyme and product separate. Okay, when the product has been produced, so the product will be separated from the enzyme. Okay, so this is the product made. This is the perhaps the byproduct. Okay, so they involve of 3 steps: ES complex, EP complex, and product. These steps are important for you to understand in the coming subtopic. Okay. So here is the general form of the product formation from substrate and enzyme. Okay, for the enzyme kinetic, it will involve the 3 steps just now. So we go through what is enzyme kinetics. Enzyme kinetics is the quantitative study of the enzyme catalysis. Okay, quantitative study on how much substrate producing how much product. Okay. Kinetic studies measure the reaction rates, okay, and the affinity of enzyme for substrates and inhibitors. So this kinetic study provide insight into reaction mechanism. Okay, again, this is the general part, which is substrate react with enzyme to produce the product. Okay, if the concentration of substrate and product are measured with respect to time, the product concentration will increase and reach a maximum value, whereas the substrate concentration will decrease. So when substrate react with enzyme, along the way, it will produce product. So the higher the product, then the substrate amount will be reduced because has been consumed by the enzyme to produce the product. Okay, so they works vice versa. Okay, product maximum, substrate will be lesser. Okay, will be minimum. Okay, enzyme form a complex with substrate, step 1 just now. Then it breaks down to the products and regenerates the free enzyme. This is the step 3. Okay, so this is the mechanism of one substrate enzyme reaction. One substrate enzyme reaction. Okay, so we have substrate, enzyme, enzyme substrate. Okay, we have here, this is a reversible reaction. K1 is the constant when substrate attached to the enzyme. Okay, when enzyme substrate re-separated, reverse process, it is K2. Sometimes we will see as, sometimes you see this K2, sometimes they write as K negative 1, meaning that the reversible of first reaction. Okay, so step 3, once you have the ES, enzyme combined with the substrate, then here is the process of product formation, the K3. Okay, so once the product formed and completed, it will be separated from the enzyme. Okay, so here you have K1, K2, and K3. This one is for step 1, step 2, step 3. Okay, each step has their own reaction rate. Okay, there are a few mathematical models to measure the kinetic of enzyme. One of it is Michaelis-Menten. We will study 3, Michaelis-Menten or saturation kinetics, okay, MM. Later on, you will see Line-Beaver, and the third one is Hannes-Wolff. Okay, there are 3 models that we will cover. Okay, MM kinetics. This one is the general enzyme reaction, okay, where it involves just now, as I mentioned, the 3 steps. Here it note as K negative 1. Okay. Now for the rate for product formation, note as V, product formation. Sometimes the statement, the question replace as term velocity. Okay, so V refers to product or velocity. Now the product formation is depending dP over dt, where K2 multiplied by the ES. Okay, K2 multiplied by ES to find the product over time, the rate of formation. Rate of variation of ES complex. So this is the one. Okay, you just need to understand how it works. The equation will be given. Conservation of enzyme equals to E naught minus ES. Okay, E naught minus ES. E naught usually will be given the value. Okay, how much enzyme is used. Now this is MM. Now for MM, it is defined as when VM, okay, half of VM is equivalent to the S. Sorry, Okay, sorry, I rephrase. VM is the maximum product produced. Again, just now V is the rate of product formation. VM assume that rate of reverse reaction of the second step is negligible. Rate of reverse reaction. Okay, so it is negligible. This assumption is only when product accumulation is negligible at the beginning of the reaction. Let's say we neglect the product accumulation. There is no product accumulation. Okay, a straightforward reaction. E plus S, then you have the ES combination, then you have product formation. Okay, so for the MM, there are two major approaches. We have rapid and quasi-steady state. Yeah, this term, don't confuse yourself. K1, reversible is K negative 1. K2, some terms use it as K1, K2, or K3. Okay, it means the constant for stage 2, this one is for stage 2, this one is constant for stage 3 when you have the product formation. Okay, for MM, usually this kind of curve you should observe. Okay, for the MM. In order for you to find the VM, what is the VM and what is the KM? So S equivalent to the KM. KM over here is the MM constant. Usually the question will ask you to find the KM. When Km equals to the S, okay, there are a few cases. Later on in the next slide, you will see there are 3 cases. In this case, Km equals to substrate. So when Km equals to substrate, it is equivalent to half Vm. Okay, so this one is fixed. Huh? Whenever S equals to the Km, it will denote on the y-axis half of Vm. Okay. Now for the first case of MM, rapid equilibrium approach. This is the equation that you need to know. Km here is the MM constant, Michaelis maintain. Okay, so from the original equation, the V, dP, dt, all those things, this is the finalized version. Michaelis maintain. Okay, V here is the rate of product formation. Vm is the maximum. M here denote as maximum. Okay, then from this graph, okay, then from this slide, okay, the term here you see maximum forward velocity referring to the Vm. where it is the maximum product formation. Okay. VM changes if more enzyme is added, but the addition of more substrate has no influence to VM. Okay. How VM change if more enzyme is added, but not when substrate is added? What do you think? Mm-hmm. Okay, how why enzyme more you have more product, but substrate more not more product? Why is it? Rate reaction of the product. Mm-hmm. When you have enzyme. Mm-hmm. Why? Mm-hmm. Okay. Okay. How about the rest? What do you think? Energy. Energy for enzyme to react with the substrate. In general here, we will not discuss in details on the energy. Yes, energy will affect as well. But in general, how is enzyme affecting the reaction? Shui-Chen, what do you think? Okay, remember this one. Enzyme provide the vacant site of the reaction. Okay, so if you have more enzyme with similar amount of substrate, so you will have more active site for the reaction to occur. Okay, more active site. But if you have limited amount of enzyme with same number of substrate, you will have less active site. Okay, for example, let's say you have, for example, 5 ml of enzyme plus 10 ml of substrate. Okay, this one considering, this one is for you to understand only. Let's say 1-to-1 ratio. So 1 ml attached to 1 ml, 1 ml substrate attached to 1 ml enzyme. Okay, this one for your understanding. Now here you have substrate more, but less enzyme. So less active site for the reaction to occur. But if you have, let's say, 10 ml of enzyme plus 10 ml of substrate, equivalent ratio of the active site. So you will have more product over here, more product, whereby here you will have less product. Okay, enzyme is the active site required for the reaction to occur. If you have more substrate over here, more substrate, so the remaining substrate has no active site to react. So here the enzyme is the limiting factor. Okay? Can okay, so that explains this point. More enzyme added, VM changes if more enzyme added, but the addition of more substrate has no influence. Okay, the active site is important. So the Km is the mm constant. Low Km suggests that the enzyme has high affinity to the substrate. Okay, so Km corresponds to the substrate concentration, giving the half maximal reaction velocity. Okay, so here, when Km equals to S, equals to substrate, it is when V equivalent to half of Vm. Okay, Vm over here. So let's say half Vm. Now at this point, this substrate value equivalent to the Km. Okay. Okay, this one is for second case where you have quasi-steady state approach. Okay, the final equation almost similar. This is the final equation. It's just there are different approach. Okay, usually the question will gives you the substrate value over time. Okay, then you will need to plot the graph. So from the graph plotted, you will find what is the Km value. This equation, Km value and Vm value. Substrate and product data. So from there, you will need to plot either substrate over time or product over time. Okay, later we'll do exercise, then you understand more. Any question for the Michaelis Menten kinetics? Important equation is this one. Where is the equation just now? Here. Okay, Vm okay, this one means concentration multiplied by the concentration of the substrate. Okay, this is equation. Now for Lineweaver-Burk plot from the just now, okay, this one, it linearized the equation. Okay, it linearized the equation. This equation will be used to plot the Lineweaver plot, where from this equation, you can find the Vm, Km, okay, from the slope and the cross. Okay, so you have to plot 1 over V versus 1 over S. Okay, this is y-axis, x-axis. Okay, Km you can find from the slope and the intercept, you can find the VM. Okay, this is what I meant just now. When you have three cases, when S equals to Km, the original equation, which is this one, will reduce to this. Okay, how? Km equals to S. So this Km replaced by the S. Okay, that's how you get V max over 2. Okay, V max over 2. Remember just now the Michaelis maintain V, Vm, this is S. Okay, when S equals to Km, half of V max. Okay, so half of it, half of the V max is S over equals to Km. This one explain the Michaelis maintain just now. Okay. Now when S larger than Km, the equation reduces to this. Km S larger than Km. Okay, so it convert to this, then the V equals to V max. Okay, when S smaller than Km, then it reduces to this. Okay, so there are three cases over here that will determine your V max and Km value. Okay. Now for the Lineweaver-Burk plot, it will be a linear line. The just now, curved line. Okay, it depends to the data given. Straight away, plot the graph based on the data given, either substrate over time or product over time. But for Lineweaver-Burk plot, you will need to linearize it. So you will need to plot 1 over V versus 1 over S. From the intercept, you'll get 1 over V max. Okay, any question on this Lineweaver-Burk? Now, for example, you have this data at different concentration of substrate. Amount of enzyme is kept constant. Velocity is expressed in terms of micromole product. Velocity here is the V, the product, rate of product formation. Okay, so these are the data up to 8 run. The question asks you to identify the values of Km and Vm for the enzyme kinetics. Okay, this one, under Lineweaver-Burk plot. So you will need to plot a linear line. Linear, so 1 over V versus 1 over S. Okay, from this equation. Now you have to convert the V into 1 over V. S convert into 1 over S. That means you should have extra set of data. Extra set of info. 1 over S, 1 over V. Okay. Now from here, plot the graph. The slope. Okay, this is the slope. Slope is equivalent to Km over V max. whereby the intercept over here is 1 over Vmax. So from here, you can find out what is your Vm. Once you get your Vm, plug in into this equation, you'll get the Km. Okay, for example, like this. Is it too small? Now let me enlarge the thing. Okay, for example, just now we have the m, the slope is equivalent here, 7, 10 power of 8. Okay, this is from the slope. From the line that you plotted, you get this value of slope. Okay, so this is the intercept. From here, from the slope, you can recalculate to find the Vmax. Okay, so this is your Vmax obtained. Then from the, once you get the Vmax, okay, Vmax, plug in into this equation. You'll get your Km. Okay. Now, next we move to Hannes-Wolff plot. This is the equation where you will need to plot SV versus the S. Okay. Note the difference. Hannes-Wolff is SV versus S. The line Weaver plot just now is 1 over V versus 1 over S. Similar to the line Weaver plot, you will need to find out the slope and the intercept. Sorry? Huh? What do you mean page what? The slide. It's not in your slide. Page 24. Not there. I will update the latest slide. I will update this one. Okay. Now this one, Hannes-Wolff plot. You will need to find out the slope and also the intercept as well. Okay, but Hannes-Wolff is S over V. The line Weaver plot is 1 over V versus 1 over S. Okay, this one, S over V versus S. Okay. The MM, V versus S. Okay. Okay, now we move to the, okay, this one is the summary of the relation Km and Vm. Okay, you can read through. We move to the exercise so that you can understand better. Okay, let's say you're given this data. Now, the following data obtained under enzyme catalyzed reaction at various substrate concentration. So these are the substrate. This is the R. Okay. Now, it asks you to plot the R versus S value and calculate the MM constant. MM constant. So MM constant, Michaelis maintain, you will need to plot V versus S. Okay. So here, the R, the rate, it use R. Letter R. By right, this one rate is the V. Okay, in the previous slide, rate we use V. Okay, in this question, it used the R. So V versus S, you need to plot this. From here, plot V versus S. Try to plot. Manual plotting should be enough. Try to plot. How is the trend that you get? For A here, using MM plot. The Michaelis maintain. So the Michaelis maintain, theoretically, it should be the curve plot. Okay, so from here, you can calculate the value of Km. MM constant here refers to Km. For Michaelis maintain, we know that half of V, this S value, okay, this S value is equivalent to Km. So from A, you will need to plot the curve, then take the value at half V, bring down, then you will get the Km value. For the B1, Lineweaver-Burk plot, this one is the linear plot. The linear equation okay, so this is for Lineweaver-Burk plot using this equation. So you need to plot a linear line 1 over V versus 1 over S. Okay, try to do this two first. try to plot in test because of exam will be very long. Now just try to plot it. use the Hannes-Wolf equation. I copy and paste the equation. So you should use this equation for the Hannes-Wolf C. Okay, plot a linear line as well, but between SV versus S. This is your Y, this is your X. Okay, the line we will plot just now, this is your Y, 1 over V, 1 over S is your X. For C similar to B, find the intercept and find the slope. Okay, for Hannes-Wolf, from the slope is equivalent to 1 over Vm. Whereby for LB, line we will book, intercept is your 1 over V. For B and C, the range of value should not be deviate too much from the initial value given here. Here, actually, this one is your Vm from Michaelis-Menten. Okay, Vm from Michaelis-Menten. So for B and C, it should not deviate too much from this value. I think Mahbubur got Vm equals to 14 something. 14. Again, it depends to the plot. As of now, you are using just manual plotting. Okay, hand plotting. So the value might deviate a bit. The Km, roughly you will get similar to the A value. Which in the A value, you get something around 1.7 to 1.8. Basically lesser than 2. Okay. Okay, so try to plot, because you need to know the steps. Before you plot, you need to know the steps. What are the infos that you require? For the honey's wolf here, since y is your SV, so you will need to calculate for SV. Find the value for each point. Okay, any question before we stop? Clear on plotting the plots? Okay, if no questions, we shall stop over here. Next class, I will continue on the following subtopic.